Hey everybody, we are going to start into quadratic relationships, but before we do, I want us to understand what we would use linear relationships for and what we can use quadratic relationships for. So linear relationships, I'll give you a pretty good example. If you get one burger from Culver's, one butter burger, it'll cost you $2.50. If you get two burgers, 1, 2, 3, 4. If you get two burgers from Culver's, two butter burgers, it'll cost you $5, $2.50. If you get three burgers, maybe you're hungry, or you're pigging out, or you're getting it for your family, whatever, $7.50. Four burgers, $10. It's a linear relationship. They're not going to charge you more for the next burger. They're not going to be like, the first burger is $2.50, but the next one, $5. The one after that, $20. They're just going to keep charging you the same amount per burger. So you can draw this linear relationship like that. And you know that even if you get 100 burgers, it'll just be $2.50 a burger. So 100 burgers, it'll be $250 using that linear relationship. What then is the purpose of quadratics? Before I tell you the purpose of quadratics, let me show you a visual representation of a quadratic. A visual graphical representation of a quadratic, also known as a parabola, is before you. Let's focus on this positive side. Let me label my axes. We're no longer working in the real world. We're back to the abstract, my x and y axes. And here's my quadratic function or my quadratic equation. Whether I'm using f of x or g of x or h of x, that'll be a function form. Whether I'm using y, that'll be the equation form. Let's go with f of x for now, just to change it up a little bit. Let's call this f of x. That is a quadratic relationship. That's a parabola before you. And you might use a parabola to map acceleration in a car. Do you start up your car and just put it into drive and then just go like at 1 or 2 miles per hour all the way to work? No, chances are you'll probably start off slow, and then from that slow speed, you'll pick up speed, and you'll constantly be going at a faster rate. So if you want to look at me modeling that with my beautiful car here. Your car starts off, sorry, this is a terrible car. But you guys get the idea. Your car starts off and it goes, vroom, 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 vroom. And that can be modeled visually. Vroom, 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 vroom. Just one example. You can also use it for modeling trajectories of things. You throw a football. Yeah, it won't look like this parabola. It'll look more like something like this. You throw a football. Let's say that this is you right there. You throw a football. It'll look something like that. That's a parabola. I mean, you just got to extend it this way. Keep it going. Got to extend it that way. Keep it going. But the concept of parabola is just some curved U-like thing that represents a quadratic relationship. So parabolas represent visually a quadratic relationship. These are both parabolas. Parabolas just represent quadratic relationships. Another important key term that you'll be hearing me use a lot is vertex. There's this parabola's vertex. Let me label this one. We can call this one the football one. Oh, we already have F. Let's go with b of x. It doesn't matter what you call it. It's just some other function. B of x. All right. We have our parabolas, and we also have, here we have this point where the parabola goes from decreasing to increasing. And right about there, we have the same point. And those points are called the vertices, or the vertex. The vertex of a parabola. It's the point that is highest or lowest in that quadratic relationship. It's the point where your quadratic relationship changes from decreasing to increasing or increasing to decreasing. Last little bit about quadratics. We read a quadratic function the same way that we read a linear function. With linear functions, some line like this, positive slope, positive slope, positive slope, negative slope, because we're reading it left to right. So this quadratic is positively sloped, because left to right, it ends that way. It's positively sloped. This quadratic is negatively sloped, because you read it left to right. This quadratic is going to be negative. So that's the concept behind quadratics. Now I'm going to graph the most basic quadratic equation that I could think of. We're going to step away from function form. We're going to go back to equations with two variables, which I think you guys maybe prefer at this point. Maybe that'll change over time. But we're going to go back and we're going to graph the most basic quadratic equation I can think of. Y equals x squared. What does that look like? Well, before we graph it visually, let's use our table method to understand what it looks like. Let's start over here. We want to understand what it looks like using our table method. We're going to have to use positives and negatives. I'm just going to give you the values this time around. You're welcome to guess. Unlike linear equations, sometimes you need 3, 4, 5, not variables, points, coordinate points. Sometimes you need 3, 4, 5 coordinate points. You need that many coordinate points to be able to accurately be able to model. I can see it. I can see that parabola. Whereas with a line, 2 points, connect those points, you got your line. So it's a little bit more complicated. I'm going to choose the points this time. I'm going to choose the x values that we plug in. It's going to be quite a few: -4, -3, -2, -1, 0, 1, 2, 3, and 4. All right, let's plug them all in. -4 is going to be squared. If you plug that in for x, you should get the y. So y will be 16 when x is -4. Let's plug in -3 for x. -3 squared will be 9 when x is -3, y is 9. When x is -2 squared, y is 4. When x is -1, you plug it in again. -1, you square it. That gets you y is equal to 1. When you square 0, you get 0. When you square 1, you get 1. You square 2, you get 4. You square 3, you get 9. You square 4, you get 16. Some of you guys might have noticed, you square a -4 or a +4, you get the same value. Yeah, that's the interesting thing about quadratics. Now, the more interesting part, let's graph them. Let's graph these points. We got our x, we got our y. I'm not going to, these will not be drawn to scale. I'm going to widen out my x-axis a little bit and shorten my y-axis a little bit, just so that you guys can see the visual representation. So 1, 2, 3, 4. -1, 2, 3, 4. -1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. We got our axes labeled. Let's plug these points in. So this first one is going to be -4, 16. This next one's going to be -3, 9, then -2, 4, then -1, whoops. -1, 1, 0, 0, so on and so forth. Let's plug these points in. -4, 16. -3, 9. -2, +4. -1, 1. 0, 0. Okay, we've got that side. We'll connect it in a second. Let's just visualize these, or let's write these out real quick. 1, 1, 2, 4, 3, 9, and 4, 16. All right, 1, 1, 2, 4, 3, 9, 4, 16. Now the tricky part, tricky for some. I'm a seasoned drawer. Watch me mess it up. Yeah, I messed it up a little bit. As you guys can see through my sloppy drawing, you got your parabola right there in front of you. You got this quadratic relationship visualized graphically. So I just wanted to leave you guys with that. The most basic, let me trace it over in blue. The most basic quadratic is going to be x squared. Y equals x squared. Y equals x squared. We're going to explore a little bit more about quadratics in the next video, though. Thank you. Cheers. See you next time.